Ladies and gentlemen, welcome to section 12.5 simulations. We're going to jump right into the section with some vocab words. Theoretical probability is what should happen, right? Theoretical is what should occur in a probability experiment. So if you flip a coin 2 times, you should get 1 head and 1 tail. You roll a 6-sided die 1 time, or 6 times, you should get 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. It's what should happen in an experiment. An experimental probability is what actually occurs when conducting a probability experiment, because we all know if we flip a coin 2 times, we might get 2 heads in a row or 2 tails in a row or 1 of each. And then finally, relative frequency is the number of times an outcome occurred because we'll be using a frequency table, but occurred in a probability experiment. So with that frequency table, here it is. We have a die is rolled 50 times and the results are right here. Frequency is the amount of times it happened. So let's find the experimental probability of rolling a 5. So our outcome we wanted was a 5 and it happened 6 times. So the experimental probability is 6 over how many times did it happen? 50. And then let's simplify this stuff. We can take a 2 out of the top, 2 out of the bottom to get 3/25. Let's find the experimental probability of rolling at least a 5. Well, at least a 5 is all of these guys, my nice straight lines, because you can roll a 4, and that's at least a 5, a 3, a 2, and a 1. So what do we have to do? We have to add up the 6 plus the 10 plus the 14 plus the 7 and plus the 6 to get 43, and that is 43 out of 50 for the experimental probability of rolling at least a 5. And then finally, find the experimental probability of rolling a prime number. Well, what numbers are prime? 1's prime, 3 is prime, 5 is prime, and what's the tricky one here? Actually, 2 is prime as well. So we add those up. We go 6 plus 10, that's not a very good 6. We go 6 plus 10 plus 14 plus 6 to get 36. And that's going to be, I'm going to move down here, 36 out of 50, which simplifies, take a 2 out of the top and bottom, that's going to be 18 out of 25. Cannot get any simpler than that. 18 out of 25. And some more vocab words. First we have simulation is using an object to act out an event that would be difficult or impractical to perform, such as bungee jumping. 1 out of every 3 bungee jumpers, the bungee cord snaps. But now that's not actually true, so go out and bungee. It's might be fun. I wouldn't know. Anyway, probability model is a mathematical model used to represent the outcomes of an experiment. Now let's see if we can design a probability model. Here we have Mandy as a pitcher on her high school softball team. Last season, 70% of her pitches were strikes. Design a simulation that can be used to estimate the probability of Mandy's next pitch as a strike. Well, we need to know the important information is 70%. Well, we could have a little bag, right, that we could draw 70% strike. So we could have a little piece of paper with an S and 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 an S. All those S's would represent strikes, and then the B's would represent the balls, or you could make it a 10-sided die that we have 1 through 7 would be strikes, and then 8, 9, and 10 would be balls. Any model that you would make would have to have 70% strikes and 30% balls. And ladies and gentlemen, that does it for section 12.5 simulations. Good day.